All right, welcome to the lesson today. We're on lesson 8, Organic Reactions. We'll be doing note pages 22 to 25 and practice packet 25 to 30. We're going to try to characterize organic reactions by the reactant and product. And let's go ahead and dive into the lesson by turning to page 22 in your notes. All right, 22. Let's zoom in here a little bit. We have organic reactions. We have 7 total. I'll just go through them. It's not super exciting, but hopefully you're attentive and try to keep in mind what are the things we're reacting so we can predict the products. Let's go ahead and begin. Yeah. Combustion. Combustion, of course, you probably recognize as something when we burn gasoline. It's other things as well, like propane, which is C3H8. And you'll need to know that you need oxygen in that mix. And make sure my sound is good. Good. And when you burn propane and oxygen, you'll get CO2, which is a greenhouse gas. You'll also get H2O, which is a great thing to get. The idea is that combustion is any alkane being burnt in the presence of oxygen to get carbon dioxide. And surprise, surprise, water. That is combustion in a nutshell. You have to memorize that one. It's a fairly common one. All right. In fact, let me just adjust this. All right, let's move on. Okay, we have substitution. All right, good. I needed more room for the writing. You need less of me anyway. Substitution, if you add hydrogen atoms to a saturated alkane. So, for example, we have C3H8, again, propane, we add chlorine gas. We can actually substitute one of the hydrogens for one of the chlorines, and we'll get back hydrochloric acid. So what is substitution? In this case, we started with an alkane. We get a halogen. We get what we call a halocarbon. And an acid. That's for a halogen substitution. What's happening chemically, and this is why I had you guys make models, is we start with our propane. We add chlorine. And one of the chlorines attach itself because of its reactivity to hydrogen to give us the halocarbon and acid. All right, addition reactions, you might have guessed, is going to involve the addition of something new, and you need an unsaturated double or triple bond hydrocarbon to become saturated hydrocarbon. And so let's go ahead and do that. If we have C2H4, you add chlorine gas to it, you'll get C2H4, but Cl2. What happened there is you'll start with an alkene or an alkyne, and you add a halogen, and you'll end up with a halocarbon. So we'll have that double bonded alkene, and you're adding chlorine. Chlorine is a reactive gas, so it will attack that double bond, freeing that double bond. And so all the hydrogens are there, but now instead of a double bond, a chlorine is attached to each end of that. All right, next one. So we got 3 out of the 7. Esterification, which I talked to a little bit about yesterday, but esterification is when you have an organic acid, let's say ethanoic acid, CH3COOH, and you add an alcohol, CH3OH, methanol in this case. What you'll end up with is an ester formed, CH3COOCH3, and water. So the general form is an organic acid plus an alcohol will give us an ester and water. I don't know why in my mind I think of esters as very aromatic, like aromatic in the sense of it smells nice. But let's move on to a structure and what's happening. We have CH3, C double bond O, OH. And if you recall, we have methanol, which I'm going to write the OH over here on this side. And what you'll see happens is this and this combine to get us water, but it will create a link. Now there's an opening where the 2 dashed part of the compounds combine to form a new ester link compound. And this is the ester link I talked about. And that's the ester. Okay, saponification, which is actually a big part. Esterification. Saponification is making soap. Esters are always on the left side. Ester reacts with inorganic base, like KOH, to produce an alcohol, glycerol, and soap. Producing soap and glycerol from fat and a strong base. That's basically. So we take an ester, a base, we get an alcohol, and soap. This is an example, of esters, triglycerides, which are in your bloodstream. And if you mix them with a strong base, you'll get glycerol and sodium palmitate, which is a soap. Now to identify these, you have to use table R. It's just too hard to memorize everything that we're doing, so try to use those. And this reaction is very complicated looking, so don't worry about memorizing it. Just try to recognize ester links when you see them, even in complicated things. All right, one of the things that I almost studied in college instead of polymer science is fermentation chemistry. It's the production of alcohol and CO2 from sugar, in the specific case yeast, called an enzyme that breaks glucose into CO2 and ethanol. CO2 and ethanol should be and. We must know this example cold. So this is an important part of biology. So we take something simple, which is sugar, C6H12O6, which is a sugar. And sugar decomposes to C2H5. Now this one you want to remember too, because it's ethanol, but it's an alcohol that mammals can drink. Alcohol, but it also produces bubbles, which you might notice in champagne. That's carbon dioxide. The last of the reactions are polymerization. And polymerization is cool because it takes little small units and creates very large units. And it's a formation of large molecules called polymers, many units, polymers, organic compounds made up of chains of smaller units covalently bonded together to form called monomers, which is their starting. Small molecules, monomers, join together to form a larger molecule, polymer. Polymers are large molecules with a unique characteristic. Examples are natural polymers are starch, cellulose, and protein. Example of synthetic polymers are plastics, nylons, rayons, and polyester. In essence, a lot of these are plastics. Addition polymerization takes place when you have two ethene molecules. You can react them and they'll form polyethylene, which is very common, like we make kayaks out of those. It's a nice stacking plastic, pretty strong and weather resistant, and that's polyethylene. You'll see in products it will be initial PE. And you should have one more called, I don't know why it's not turning, called condensation polymerization. Sorry, let me just show that to you really quick. You'll have to draw a benzene, which is 6 carbon unit. Draw a double bonded acid group on each end. And then you take ethylene, and what you get out is water. And what you get is then a long chain and this is like polystyrene. And what are you expected to know about this? You're expected to identify the link, to name the link if you need to, like this is an ester link, and name the products and the reactants. So looks like esters with an alkene give you a polymer. And this polymer can go on and on and on. This is called, oh, by the way, condensation reaction. You basically remove an OH group to form H2O, which is why you produce water. And that is it for organic reactions and our no packet. Now we just practice. Stay tuned for a video maybe on the practice packet, but thanks for listening.